Hello everyone. So today we are going to solve candy problem. It's an hard level problem on LeetCode. So first let me go through this question. So given that there are n children standing in a line, each child is assigned a rating value. So what the mean is, so there are n children standing in a line. So like this, and every child has certain rating assigned to him or her. So I have given some example ratings. So you can see that child 1 has a rating of 3, child 2 has a rating of 2, child 3 has a rating of 4, and so on. And the next dimension is you are giving candidates, sorry, you are giving candies to the children subjected to the following requirements. So So our task is to distribute the candies to these children so that it satisfies these both conditions. So the first condition is each child must have at least one candy. So what does this condition mean is, so every child who is standing in the line should get at least one candy. So that no child should be remaining with zero candies. Okay. So in the second statement mean children with higher rating get more candies than their neighbors. So this statement means, so let us take an example of this first two childs. So here the rating of the first child has is higher than the rating of the second child. So now, if we distribute two candies to this second child, since the first child has a greater rating compared to the child's neighbor, so he should get greater than two candies. So he can get three candies, he can get four candies, he can get any number of candies, but it should be greater than the number of candies which we given to his neighbor. Since this child has less rating compared to the first child. Okay. So now the question is return the minimum number of candies you need to distribute to the children. So basically what they are asking is, so let's get back to the same example. Here we are given the two candies to the second child. So then we should give higher number of candies greater than 2. So we can give 3, we can give 4. So but they ask the minimum number of candies we need to distribute. So to distribute the minimum number of candies, we can 3 candies is enough to the child one. So no need of the giving 4 candies. Since if you give 3 candies, it satisfies the both conditions. The first condition is each child should be getting at least one candy. It satisfies the first condition, and the children with higher rating should get more candies compared to their neighbors. It also satisfies the second condition. So, like this, we have to find the minimum number of candies to distribute among all the children. So, this problem can be solved simply by using curves. So, So I will show you like how to use these curves. So first, let us use this example rating array to plot a curve. So the first element is 1. So let's first point this 1. So the next element is 0. Since the element is lower, so we will be decreasing the slope of the curve. So now the curve looks like this. After the 0, the next element is 2. Since the element is greater, so we will again increase the slope of the curve. So now the element 2. And next, after that, the 3 is the next element. So since it is greater than 2, the curve still goes on increasing. 3. And the last element is 1. So now 1 is lower, I mean lesser element than 3. So now the curve goes down. So this is as simple as that to plot the curve. So after plotting the curve, so the next thing we should do is finding the minimas. So finding the minimas in the curve. So what is a minima is basically, so if the left element is greater than the current element, let I be the current element, and left element is greater than the current element, and also the right element is greater than the current element, then we can say that this current element is a minimum. So if this condition satisfies, we can say that A of I is a minimum. So if we look at this curve, so we can say that 0 is a minima and 1 is also minima, because the left element of 0 is 1, which is basically greater than 0. The right element of 0 is 2, which is basically greater than 2. So this is a minima which satisfies this condition. And at looking at 1, we can say that the left element is 3, which is greater than 1, and it doesn't have any right element, so it satisfies this condition. So this is also a minimum. So after finding all the minimas, so the next step we'll be doing is, so from we will be start distributing candies from the minimas itself. So how we will be doing that is, so let us take the first minima, that is 0. So for the 0, first we will give the a single candy. So this is the least possible candy which we can give. So for the 0, we'll be giving a single candy. So after that, after giving a single candy to 0, so we will be traversing left side of the 0. So then until until the greatest increasing sequence stops. So we'll be traversing left side until the increasing sequence stops. So that is increasing sequence stop. So if we see that the left side of 0 is 1, so it is an increasing sequence because 1 is greater than 0. So since 1 is greater than 0, we had given 1 candy to the 0 element. So it has the higher rating, so it should get greater number of candies. So we can give we can increment the candy count by 1, and we can give 2 candies to the 1. And since there is no other element after 1, so we will be stop traversing left side. Now we will be start traversing right side of the 0. So same, we will be traversing right side of the 0 until the increasing sequence stop. And the same thing, the increasing until the increasing sequence stop, we will be traversing. So after 0, we have 2. Since we have given a single candy to 0, so the 2 should get higher number of candies because of higher rating. So we will increment the candy count by 1. So the 2 will get 2 candies. Similarly, uh, after traversing, we'll reach 3. When we reach 3, we got to know that 2 has got 2 candies, but 3 is greater than having a higher rating than 2. So we will be incrementing the candy count, and we will be giving 3 candies to the 3. So after that, after 3, there is no increasing element. So we will stop traversing here. And then next we will go to the next minima which we found out in the first step. So the next minima is nothing but 1. So for the 1, again we will repeat the same steps. We will go traverse to the left side until an increasing sequence stop. After that, we will again traverse to the right side until an increasing sequence stop. So first going to left side. So since in this minima, we know that we will be giving one single candy to the minimas. So again, we will be giving a single candy to the minima, and after that, so the next element is 3. So see, since 3 is greater than 1, 1 has 1 candy. So 3 should get greater than 1 candy. So it can be 2, either 3. So now whenever it reaches the top point, here we will be selecting the max of. So let me write it clearly. Okay. So whenever we are updating a top element candies, so we will be updating with max of. So already from the first minima, we got to know that it needs 3 candies. So from the second minima, it can be shown we should get greater than 1 candy. So I mean greater than 1 candy. So the best possible case is 2 candies. So we will be updating the value of this element with the max of already existing value and now the incoming value. So since 3c is greater, so that why we are choosing max, it seems max because by choosing max it satisfies this side of the sequence and also this side of the sequence. But if we choose 2C, it only satisfies this side of the sequence. But if this side of the sequence doesn't justify the two conditions, so that's why we are using this condition to update the value. So that's it. To solve this problem, we'll use this approach. There is a special case where for the given example, so the curve looks some part of the curves look flat line. So for now we'll point 3. So the next point is 2, and the next point is equal to the next previous element, and again 2. So this part of this curve looks straight line. So now how to handle this? So again, so we will after plotting the curve, the next thing we will be doing is we'll finding out the minimas. So after finding the minimas, we'll get to know that so 2 is a minima because the left side element is greater than 2, 3. I mean greater than current element. So the right side element of 2 is again 2. It is equal. So but we can consider it as a minima if it is equal also. But one thing is we should check whether the left or right should be greater. So both sides should not be equal. So if any side of this is greater and other side is equal, then we can tell that it is also a minima. So so as we know, we'll again traverse to left side. So we'll give one candidate to the minima element, and we will give two candies to increment one increment one, and we'll give two candies to this three element, and after that we will traversing right side. So but while traversing right side, so it is not greater, it is not lesser than the two, I mean minimum element. So now what should we do? It is equal. So as the if we check this condition, children with highest rating should get more candies than the neighbor. But but here 2 is equal to the 2. I mean its neighbor. It is neither greater or neither lower. So we can directly give one candy to the equal elements. And similarly here. So after finding this, and again we can go left until the increasing sequence stops. I mean whenever the next down curves occur. So now we can solve this problem. So let me show my code. So the first thing I'm initializing a list, so which keeps track of all the minimas, and so from this loop I am finding all the minimas by checking the condition, minima condition, which we already explained earlier. This is the minima condition. So after finding all the minimas, so I'm I'll iterating through the minimalist. So for every minimalist, we are traversing left side of the minima and right side of the minima, and we are incrementing by one. And in every case, we are checking this max condition, like the previous candies and now incoming candies, as we already discussed. So let me run my code. Okay, it passes through all the test cases. Thank you.